In question 1a, we are asked to simplify m cubed times m to the power of 4. Well, we know when we multiply with a common base, we add the indices, so 3 plus 4 is 7, and therefore the answer will be m to the power of 7. In b, we need to simplify 5np cubed all raised to the power of 3. So we know that since everything is in the bracket, then we need to do 5 to the power of 3, which is 5 times 5 times 5, which is 125. Then it's going to be n cubed. And finally, p cubed to the power of 3. I will multiply the indices together. 3 times 3 is 9, so this will be 125 n cubed p to the power of 9. In C, we need to simplify 32q to the 9r to the 4 over 4q to the 3 times r. So I start with the numbers. 32 with 4 simplify, leaving me with an 8 and the 1 in the denominator. Now q to the 9 over q cubed is q to the power of 6. And finally r to the 4 over r is r cubed. And therefore the final answer here will be 8q to the power of 6, r to the power of 3. In 2a, we need to find the lowest common multiple of 40 and 56. So I would like to draw a table here. We've got the 40 and the 56, and I will be dividing by prime numbers until I hit 1, 1. So I divide by 2. 40 divided by 2 is 20, and 56 divided by 2 is 28. I will divide again by 2, leaving me with 10 and 14. Then again by 2, leaving me with 5 and 7. I will now divide by 5, so 5 divided by 5 is 1. 5 does not go into 7, so I'm left with the 7. And I will divide by 7, the 1 is 1. 7 divided by 7 is 1. And therefore the LCM of 40 and 56 is given by 2 times 2 times 2 times 5 times 7. In other words, the product of all the prime numbers I've written here. And this gives an answer of 280. In B, we need to write down the highest common factor of A and B. So we always pick the prime numbers in their smaller power. So I will start with 2 squared, because between 2 cubed and 2 squared, I will pick 2 squared. Now 3 is common to both, so I'm just going to take 3. And between 5 and 5 squared, obviously, I will go for 5. Which means that the highest common factor of A and B will be given by 2 squared times 3 times 5, which gives an answer of 60. In question 3, we are asked to find the equation of the line L, shown here on the grid. I will start by considering the gradient, and we know that the gradient is rise over run. So I'll go back on my diagram and draw a right angle triangle as shown here. We see that the run is 2, we see that the rise is 6 units, and therefore the gradient will be 6 over 2, which is equal to 3. We also notice that we cut the y-axis at -6, and therefore C, the y-intercept, is -6. So if we consider the general equation of a straight line, which is of the form y is mx plus c, we have found m to be 3 and c to be -6, so y is 3x minus 6. In question 4, Raya buys a van for 8,500 plus VAT at 20%. She pays a deposit for the van, and she then pays the rest of the cost in 12 equal payments of £531.25 per month. And we need to find the ratio of the deposit to the total of the 12 equal payments, giving our answer in its simplest form. So I will start by finding the total cost for the van. So it's the 8,500, and I will add the 20%, which means I will multiply by 1.20. That's the multiplying factor associated with an increase by 20%. So get 10,200. Now we've got 12 equal payments of 531.25. So 531.25 times 12 gives an answer of 6375, and therefore the deposit will simply be the difference between 10,200 and 6,375, and this gives an answer of 3825. Remember, we are asked to find the ratio of the deposit, which was 3,825, to the total of the 12 payments, which is 6,375. 6.375. In order to simplify this, I can use my calculator. I treat this as a fraction. So 3825 over 6.375. You can see that it simplifies to 3 over 5 on the calculator. So that's going to be 325. In question 5, we are asked to complete the table of values for y is x squared minus x minus 6. And I could actually use my calculator here to actually produce the whole table. So I go into mode. I choose table. Now f of x will be x squared minus x minus 6. I press the equal sign. I will leave g of x empty. I will start at -3. So I will end at 3 and I will be stepping every one, which means every one I will be producing the value of y. And this will give me the table. So we can see that when x is -2, y is 0, then it's -4, then it's -6, which was already there, then -6, then -4 and 0, and we have filled in the table for 2 marks. We are then asked to draw the graph of y is x squared minus x minus 6 from -3 to 3. So obviously I will start by plotting the points with crosses. I will join them with a smooth curve, and this is the graph of y is x squared minus x minus 6. In part C, we are asked to use the graph to find estimates of the solutions to the equation x squared minus x minus 6 is -2. We should be able to recognize the left-hand side of this equation as y. So we are simply being asked to consider the intersection with the line y is -2. So I'm coming back to my graph. I draw the line y is -2. It's a horizontal line passing through all points having their y coordinate in -2. And I'm looking for the points of intersection. I see one here and another one here. I need to read off the x values. This is 2.55. And the one on the left is -1.55, which means I need to give 2 possible answers. Either x is -1.55 or x is 2.55. You need to bear in mind that the examiner here is accepting for the first value anything from -1.5 to -1.7, and for the second value anything from 2.5 up to 2.7. In question 6, we've got a force of 70 newtons acting on an area of 20 square centimeters. We increase the force by 10 newtons and increase the area by 10 square centimeters, and Helen claims that the pressure has decreased by less than 20%. We need to assess on whether Helen is correct or wrong, and we must show how we got our answer. So we do have the formula here. Pressure is force over area. So starting with the original pressure, it's going to be the 70 newtons divided by the 20 square centimeters, which gives an answer of 3.5 newtons per square centimeters. And then moving on to the new pressure, that's going to be 80 newtons because the force has increased by 10 newtons divided by 30, which is the new area. This turns out to be 8/3 newtons per squared centimeter. So we want to find the multiplying factor that will take us from the original pressure to the new pressure. So the multiplying factor is new over original. So the new is 8/3 and the original was 3.5. And this is equal to 0.7619. So the multiplying factor being 0.7619 will help me see the percentage decrease. So to find this, I will simply do 100% minus 76.19%, which leaves me with 23.81%. In other words, if I'm multiplying by 0.7619, it means that I'm only left with 76.19%, and the remaining 23.81% is the decrease. Well, we can see that this is greater than 20%, and hence we conclude that Helen is wrong. In question 7, we are asked to enlarge shape A by a scale factor of a third with center 0, 1. The center has been marked here with a cross. So I will start by drawing rays of light from the center of the enlargement to each of the vertices here. So drawing the rays, I see that they in question 7 we are asked to enlarge shape A by a scale factor of a third with center 0, 1. So the center of the enlargement has been marked with a cross here. So I will start by drawing rays of light from the center of the enlargement to each of the vertices of shape A as shown here. So I can take any of the vertices, for example this one here, and we see that to go from the center to this vertex I go 3 to the right and then 3 up. Well, the scale factor is a third, so it means I'll go 1 to the right and 1 up, so it's gonna be here. Similarly, proceeding with the rest of the vertices, I can see that the image will be exactly there, shaded in red. In 8, we've got 60 people that were asked if they prefer to go on a holiday in Britain, Spain, or Italy. 38 of them were male. 11 of the 32 people who said Britain were female. 8 males said Italy and 12 people said Spain. And we're choosing one of the females at random. What's the probability that they said Spain? I will actually start by drawing up a table here. So we've got Britain, Spain, and Italy, and males and females. We know that the total is 60 people. 38 of them were males, so the total for males is 38, which means that the total for females is 22. We then have 11 out of the 32 people who said Britain being female. So for Britain, we've got 32 people, 11 were female, so the other 21 were males. We have 8 males that said Italy, so 8 males said Italy. So 21 plus 8 is 29, so we need another 9 for Spain to make the total 38 for males. And then we've got 12 people that said Spain, so 12 goes here, so this must be 3. And then 11 plus 3 is 14, so another 8 to make the total for females 22. And we are told that we're choosing one of the females at random. This means I will only concentrate on the row for females. We've got 22 females in total. We're being asked for the probability that this female said Spain. We've got 3 females that said Spain out of a total of 22. So the answer here is 3 out of 22. In 9, we had an investment of 12,000 in an account paying compound interest for 2 years. For the first year, the rate of interest was X%, resulting in an investment worth £12,336 at the end of the first year. For the second year, it went down to X over 2%, and we need to work out the investment at the end of the 2 years. I will start by reminding us that the multiplying factor is the new over the original. I'm concentrating on the first year. So at the end of the first year, it was 12,336. At the beginning, it was 12,000. This means that we're looking at a multiplying factor of 1.028, which corresponds to an increase by 2.8%. And therefore, we conclude that X must be 2.8. So for the second year, we were told that the rate of interest is X over 2. So X over 2 will be 2.8 over 2, which is 1.4. So if I want to increase something by 1.4%, this corresponds to a multiplying factor which is 1.014. So I will take the value of the investment at the end of the first year, which was 12,336, multiply this by 1.014, giving an answer of £12,508.70. In question 10, we've got the vectors A and B shown on the grid, and we need to draw and label the vector negative 2A. Well, the vector A, as you can see, is the vector that will take you 1 unit to the right and 2 units up. So if I multiply this by negative 2, I will be going 2 to the left and then 4 down. so it should look something like this. You can draw this anywhere. The important thing is to see the vector going 2 to the left and 4 down, so it is crucial to include the arrow as well. If vector A is taking you up and to the right, then the vector -2a is taking you to the left and down. We are then asked to work out a plus 2b as a column vector. We're looking at b here. We can see that we go 1 to the right and then 3 down. So the 3 down will appear as a -3. So when we come to do a plus 2b, well, the vector a is 1, 2, and the vector b is the vector 1, -3. So this will give me 1, 2, plus 2, -6. Adding the top entries 1 and 2 is 3. And adding the bottom entries 2 plus -6 is -4. So a plus 2b will be 3, -4. In 11, we're given the function f of x and g of x, and we are asked to work out f of -5. So f of -5 simply means substitute x with the value of -5. Be careful with the brackets, it's -5 all squared. So this gives an answer of 2 over 25. In B, we need to find f of g of 1. This is a composite function. Remember, we start with the inside. We first need to do g of 1. So it's going to be f of 4 times 1 cubed. And this is f of 4. So we're looking at 2 over 4 squared, which is 1 over 8. In 12, we're given 4 graphs, A, B, C, D, and we are asked to match each type of proportionality in the table to the correct graph. Well, starting with y being proportional to x, so this is direct proportion. We are always looking for a straight line passing through the origin, and the only straight line is graph B, so this is B. Now, y being proportional to x squared, we are looking for a graph that resembles the standard parabola, so something that goes like this, so it must be graph D. Now, for the root of x, if we're not sure, we can look at the next one. We've got y is proportional to 1 over x. This is inverse proportion, so as x increases, y decreases, so it's graph C here. So C is here, and by a method of elimination, the y being proportional to root x must be graph A. The square root graph looks something like this, so this matches graph A. In 13, we've got A, B, C, D points on the circumference of a circle centered at O. F, D, E, the line here is a tangent to the circle, and we need to show that y minus x is 90, providing reasons. So I will start by saying that BCD, the angle here, must be 180 minus y. The reason is that ABCD is a cyclic quadrilateral. So we know that opposite angles of a cyclic quadrilateral add up to 180. So BCD is 180 minus y, and we need to include the reason. We then proceed into saying that the angle here BDF should also be 180 minus y. This is the alternate segment theorem. Remember that between the tangent and the chord, the angle here and the angle created in the alternate segment are equal, and therefore we have that BDF is equal to 180 minus y. The reason is the alternate segment theorem. We then proceed into saying that the 180 minus y and the x should be adding up to 90 degrees because this is an angle between the tangent and the radius at the point of contact. So this here should be a right angle. So we say that 180 minus y plus x should be equal to 90, and we also provide the reason that angle between a tangent and the radius at the point of contact is 90 degrees. This means that 180 minus 90 is y minus x, and therefore 90 is y minus x as required. In part B, we are told that Dylan was asked to give some possible values for x and y, and he said that y could be 200 and x could be 110, because 200 minus 110 is 90. Well, going to our diagram here, y here is an angle in the triangle ABD, so it could never be more than 180, and therefore we conclude that Dylan is wrong since y must be less than 180 as it is an angle in a triangle. In question 14, we've got the distance time graph showing information about part of a car journey, and we need to use the graph to estimate the speed of the car at 5 seconds. Well, we know that in a distance time graph, the speed is given by the gradient of the graph. So we need to draw a tangent at 5, which is a straight line which just touches upon the graph here. So it should be something like this. So we need to find the gradient, and the gradient of this line will be the speed. So I start by identifying 2 points that lie on the line. I see that we go through 3, 0 here, and also at the very end it's 8, 72, which means I can proceed in finding the speed. Recall that the speed is the gradient, and this is y2 minus y1 over x2 minus x1. So I'll be doing 72 minus 0 over 8 minus 3. This gives an answer of 14.4 meters per second. You need to bear in mind that the examiner here is accepting answers between 11 up to and including 19. In 15, we've got a darts team who's going to play a match on Saturday and Sunday. The probability they win the match on Saturday is 0.45. And if they win on Saturday, they will win again on Sunday with probability 0.67. However, if they lose on Saturday, they will win on Sunday with probability 0.35, and we are asked to complete the tree diagram given here. So remember that the sum of the probabilities should be 1. So the probability of not winning on Saturday is 0.55. Now if they win on Saturday, they will win again on Sunday with probability 0.67. which means that they will lose with probability 0.33. But if they do not win on Saturday, the probability of them winning on Sunday is 0.35. So the probability of losing for a second time is 0.65. In part B, we need to find the probability that the team will win exactly one of the 2 matches. So we are looking at 2 scenarios here. It's either winning and not winning, or not winning and winning. Remember that we multiply the probabilities of the branches through which we travel. So it's going to be 0.45 times 0.33 plus the alternative scenario of not winning and then winning, which is 0.55 times 0.35. And this gives an answer of 0.341. In 16a, we are asked to draw the graph of x squared plus y squared is 12.25. Well, we should be able to recognize this as a circle which is centered at the origin and has a radius which is the square root of 12.25, which turns out to be 3.5. So we're looking at a circle centered at the origin having a radius of 3.5. And this looks something like this. So the center is at the origin. We can see that we cut the x-axis at 3.5 and minus 3.5 because the radius is 3.5. And similarly, we cut the y-axis at 3.5 and negative 3.5. In B, we are asked to find estimates for the solutions of the simultaneous equations x squared plus y squared is 12.25 and 2x plus y is 1. So the idea is for me to draw the line with equation 2x plus y is 1 on my graph and identify the points of intersection. So considering 2x plus y is equal to 1, I can see that when x is 0, we get that y is 1, and therefore we pass through the point 0, 1. And when x is 3, for example, I'm just going to plug in a value for x. I will substitute 2 times 3 plus y is equal to 1. So 6 plus y is 1, which means that y is negative 5. And therefore, I've got a second point through which the line passes. That's the point with coordinates 3, negative 5. So all I have to do now is plot the 2 points, the 0, 1 and the 3, -5. I'll join them with a straight line, and that's the line with equation 2x plus y is 1. Now we can see we've got a point of intersection here, so we can read the x value, it's -1.2, and the y value is 3.3. And there's another point over here which has an x coordinate of 2 and a y coordinate of -2.9, which means we conclude that x is -1.2 and y is 3.3, or the second point had x coordinate 2 and y coordinate -2.9. In 17, we're given the histogram showing information about the times taken by some students to finish a puzzle, and we need to complete the frequency table for this information. Now we know that in a histogram the area is proportional to the frequency, and the frequency density is actually the frequency over the class width, which means that the frequency density times the class width is the frequency. In other words, the area will give me the frequency. So I will go on my histogram. The point here between 0 and 10 is 5, then it's 15, then it's 25, and I will start calculating the areas. For the first bar, it has a width of 5 and a height of 0.8. So this has an area of 5 times 0.8, which is equal to 4. For the second bar, it's 10 times 0.4, which is equal to 4. For the third bar, it's 10 times 0.6, which is equal to 6. For the third bar, we've got a width of 5 and a height of 1, so it's 5 times 1, which is equal to 5. And for the last one, it's 20 times 0.2, which gives an answer of 4. And we can see that for the first bar, the 4 matches the frequency here. So we can complete the table by filling in the missing frequencies, which are 4, 6, 5, and 4. In B, we are asked to find an estimate for the lower quartile of the times taken to finish the puzzle. In order to do this, we first need to find the total frequency. So I will be doing 4 plus 4 plus 6 plus 5 plus 4, and this gives an answer of 23. For the lower quartile, it's a quarter of the data, so 23 over 4 is 5.75, and therefore I need to go back to the histogram. There it is, and I want to start from the beginning and find the value somewhere here that will give me a total area of 5.75. Well, we know that the first bar shown here in purple had an area of 5 times 0.8, which is 4, and therefore from 4 to go to 5.75 I need another 1.75 in area, and therefore this means I'm somewhere in the second group over here. So I will start by scaling this. This is 5, and I will call this point x, and in other words, it all boils down to me finding the value of x such that this here will be 1.75. So we've got 0.4, which is the height, times the width, which is x minus 5, is equal to 1.75. I will expand this to give me 0.4 x minus 2 is 1.75, which takes me to 0.4 x is equal to 3.75, and therefore x is 9.375, and we conclude that the lower quartile for the data is 9.375 minutes. In 18, we're given this cuboid here. We are told that the length of AB is 7.3 centimeters, the length of CH is 8.1 centimeters, and angle BCA is 48 degrees. We need to find the size of the angle between AH and the plane ABCD. So let me start by highlighting the plane ABCD. And if we draw the line AH, we can see that the angle we're trying to find is the angle marked theta here. Well, we've been told that AB is 7.3 centimeters and the HC is 8.1 centimeters. The angle here BCA is 48 degrees. So in order to find theta, we first need to find the length of AC, the diagonal here, and then we'll proceed in the triangle ACH. Now to find the length of AC, I will extract triangle ABC, which is a right angle triangle with all the information that we have. There it is. The AB is measuring 7.3 centimeters and the angle C is 48 degrees. And therefore I can say that sine of 48 is equal to 7.3 over AC, which means that AC sine 48 is equal to 7.3, and therefore AC is 7.3 over sine 48. This turns out to be 9.823 centimeters. So we have found the length of AC, so I can now extract the triangle AHC. So there it is. We've got AHC. AC is 9.823 centimeters. CH is 8.1 centimeters. And all we're trying to do is find the size of the angle theta. So I can easily say that tan theta is 8.1 over 9.823 . I'm using full accuracy here. This means that theta is shift tan of 8.1 over 9.823 . And therefore this leads to an answer of 39.5 degrees. We were asked to give our answer correct to 1 decimal place. In 19, we've got shape S here. It's a quarter of a solid sphere centered at O. We are being told that the volume of S is 576 pi cubic centimeters, and we need to work out the surface area of S. Well, I will start by identifying the different faces on this shape and the expressions corresponding to the area. So this part here is half a circle, so the area should be a half pi r squared, simply using the fact that the area of a full circle is pi r squared. Similarly, this part here is another half circle, so that has an area of a half pi r squared. And then this part here, well, it's a quarter of a solid sphere, so the area there should be a quarter of the surface area of a sphere, so that should be a quarter of 4 pi r squared. Now let me start by using the fact that we know the volume of S is 576 pi cubic centimeters, and therefore we can easily say that since this is a quarter of a sphere, then the volume would be a quarter of 4 over 3 pi r cubed, and this gives an answer of a third pi r cubed, which is equal to 576 pi. Where the pi's will cancel out, I will cross multiply 576 with 3, leading to 1728 equal to r cubed, and therefore the third root of 1728 should be the r, which turns out to be 12. Now moving on with the surface area, we've got the half pi r squared, the half pi r squared, and the quarter of 4 pi r squared to be added up. So a half pi r squared plus a half pi r squared plus a quarter of 4 pi r squared. Now the half pi r squared and the half pi r squared give me pi r squared plus another pi r squared, because the 4 with the 4 will cancel out. This gives an answer of 2 pi r squared, and we know that the value of r is 12, so this should be 2 pi times 12 squared, which gives an answer of 905 cubic centimeters, correct to 3 significant figures. In 20, Martin was asked to rationalize the denominator of 14 over 2 plus root 3, so he starts off by multiplying by 2 minus root 3 over 2 minus root 3. He expands, everything is fine in the numerator. We are asked to find the mistake, and it's actually in the very last term in the expansion in the denominator where he has plus 3, because plus root 3 times minus root 3 is actually minus 3, so the mistake is the plus 3, and we need to explain the mistake. Well, we say that in the denominator he should have 4 plus 2 root 3 minus 2 root 3 and minus 3. We're then told that Cyan was asked to rationalize the denominator of 5 over root 12, and we need to find the mistake again here. So Cyan started off by multiplying by root 12 over root 12. He wrote root 12 as 3 root 2, and that's actually the mistake because root 12 is not 3 root 2. Root 12 is root 4 times root 3, which is 2 root 3, and that's the mistake she did. In question 21, Jackson is trying to find the density in grams per cubic centimeter of a block of wood. The measurements of these are shown here correct to the nearest millimeter. We also know that the mass is 1,970 grams to the nearest 5 grams. And by considering bounds, we need to work out the density of the wood. So let me start by reminding ourselves that density is mass over volume. So for each of these measurements, we need to consider the upper and lower bound. So let's start off with the length. It's 13.2 centimeters, which is 132 millimeters, which means that the upper bound is 132.5 millimeters and the lower bound is 131.5 millimeters. Similarly, for the width, we've got 16.0 centimeters, which is 160 millimeters, and therefore the upper bound is 160.5 millimeters and the lower bound is 159.5 millimeters. And then we've got the height. The height is 21.7 centimeters, which is 217 millimeters, and therefore the upper bound is 217.5 millimeters and the lower bound is 216.5 millimeters. We also have the mass, which is 1970 grams, correct to the nearest 5 grams. So to find the upper bound, I go 2.5 grams up, so 1972.5 grams, and the lower bound is 1967.5 grams. And now that I've got the upper and the lower bound for each of the measurements, I can proceed into finding the upper bound for the density. So density is mass over volume. To find the upper bound for the density, I will take the upper bound for the mass, which is 1972.5 grams, over the lower bound of the measurements of the length, width, and height. So it's 13.15 centimeters times 15.95 centimeters times 21.65 centimeters. I have converted everything into centimeters to get an answer in grams per cubic centimeters. This gives an answer of 0.43438 grams per cubic centimeter. Similarly, I can proceed in finding the lower bound for the density. So that will be the lower bound for the mass, 1967.5, over the upper bound for the length, the width, and the height. So 13.25 centimeters times 16.05 times 21.75, and this gives an answer of 0.42537 grams per cubic centimeters, which means that at the moment we don't really know the exact value of the density, but we know that it lies between 0.43438 and 0.42537. Remember, we were asked to give our answer to a suitable degree of accuracy, so we notice that whatever the true value, it has to be 0.43 to two significant figures, because both the upper and the lower bounds agreed to 2SF to 0.43. If I was to round them to 3SF, the upper bound would have been 0.434 and the lower bound 0.425. So there's a disagreement, but they certainly agreed to 2SF to the value of 0.43. And therefore we conclude that since both bounds round to 0.43 to 2SF, we can say that the density is 0.43 grams per cubic centimeter.